All right, so welcome. Now we are in week number 3. I hope that you have started the assignment with your colleagues in the team. If you face any difficulties, let me know. Okay, just send me an email. Then I'll respond to it. Right. Okay. Let's go through now. Remember, week 6 we have the test. Right, I can't remember, is it week 6 or week 7? I mean, one of these weeks we have the first test. So all the bits and pieces we are learning in the lectures and also in our tutorials or labs are very important, right? So I strongly urging you to practice it more and more, because it checks your how fast you are as well, right? So it all multiple choice questions. So remember, 80 questions within 60 minutes. It's a open book, right? It's a bit of a challenge. So I'll strongly urging you to just practice the questions, and also I don't know whether I have published 2 practice tests. If it is not there, I will make it available probably tonight. Okay. So when the semester progresses, you can do some questions from there as well. All right, so let's get started today's session. So now we are in week 3, so we're moving into a little bit advanced topics. Okay. Um, all right, now let's go through some of the stuff that we have learned last week. Let's catch up some stuff, because we need to really wanted to make sure that everybody is in the same page, right? Now remember, last week we have learned 2 important functions, upper function and the lower function, right? So why we use these 2 functions? Because if you want to convert some character set into uppercase version or lowercase version, we can use the upper and lower function, right? Now remember, when you use upper and lower functions, it will not physically convert anything in our table, right? So usually we use these 2 functions either in select statement or within the where clause, right? So upper function basically converted to the uppercase, and the lower function convert into lowercase, right? So remember, the numbers and punctuations will not going to affect, right? So it's not affected, so it will not going to change, and you will not get any error message as well, right? Right, so let's go through some more examples to clarify these stuff. Now imagine I have a table called a student. So there are 2 columns, student ID column and the name column. Now imagine I have only one student at the moment, right? So one record. Right, so if you run these statements, this is how my result sets look like, right? For example, if I run a select statement called select, just pick the name as is, right? That name as is appeared in my physical table from student. So that means my results looks like this, isn't it? So Jane will appear as similar as what it appeared in my table, right? The second one, select name from student where the name is Jane. So this is equal sign means exact matches, so we need to match the instance of the name column with this particular Jane. So J capital and the rest is simple, right? So it's a character, that is why we have single quotes. Yes, so we have this Jane here in the table, so I'll get back the Jane as a result. Okay, so no problem in that, straightforward. How about the third one? So the third one, again, I'm running a select statement. I want the name column from the student table, where the name, this time the name must equal to uppercase version of Jane, right? Do I have uppercase version of Jane here? No, I don't have uppercase version, so I'll not get any rows back. So I'll get a message saying 0 rows or something like that. Okay, right. So let's go to this example. fourth one. So in this case, what I am going to do here, I am actually converting everything in my name column into uppercase version, right? So my result set looks like this. So I just converted this Jane into uppercase version of Jane, right? So this is my result. The fifth one, this one, select name. So I select the name as is. This is what I want to display. The student table where, now in this case, I wanted to compare the uppercase version of the name equal to uppercase version of Jane, right? So my result is now this Jane because I want the name as is appeared in my table, right? But in this case, for the comparison purpose, now this is a very good programming habit, guys, because we can't trust the users because users can input anything here, isn't it? So always, if you want to make sure that if you want to get the Janes in the table, so better to convert that particular column into uppercase or lowercase version, and you need to compare it with that particular version. So you need to basically compare apples with apples, right? So if you compare lowercase with uppercase, you will not get any results, right? So apples with apples, same case, right? So that's what you need to remember. Sometimes we may made some mistakes in this case, right? Right. So let's go through another example. Now here the same example, same table. So let's go through these SQL statements by one by one. So in this case, select the name column from the student where uppercase version of name, right, equal to this change. So am I getting any rows back? No, I am not comparing apples with apples, right? So that means I don't get any results in back. So 0 rows, okay? Right. Second example. Now here, in this example, I am converting everything into uppercase version as for the reporting purpose, right? But here in the where clause, right, I am comparing uppercase version of name with the uppercase version of Jane. Yep, so that means I can exactly compare now. My result set is uppercase version of Jane. Why am I getting uppercase version of Jane in this case? Because I'm requesting in the select statement the result set has to be uppercase, right? So that is why I'm getting the uppercase. Yeah, I think it's clear. Right, now let's jump to the third example. Now in this third example, in the select rows, I want the name as is appeared in my physical table. But here in the where clause, I am comparing the lowercase version of the name with the lowercase version of the name, right? So again, I'm comparing apple with apples. So that means I'm getting the result set, but in this case, I get the name as is appeared in my physical table. So that Jane will appear like this. So first capital, the rest is simple, right? Same as the physical table, right? Right. How about this one? Okay, let's go through this example. I want your answers. All right. So how many rows will be displayed by each of these statements? Now imagine now we have this table, right? So we have 3 rows, or 3 instances. Now 3 different Janes here, isn't it? Right now, see, first one case, first letter is J. The second case, everything in this in the uppercase, and the third case, everything is the lowercase. All right. All right. Now, if I run the first one, okay, if I run the first one, select everything from the student where the name column is equal to uppercase version of Jane. So how many rows I will get for the first example? First example, yes, is it 1? Yes, so most of them are saying 1. So let me actually, let me take my point option, point option pen. Okay, right. So in this case, yeah. So we have only 1. Yeah. So this chain, right? So row number 3, 3, 1. Yeah, 3, 3, 1. This chain. Okay, so that's good. Okay. How about the second example? Select everything from the student where the name is equal to this chain. How many rows again? Again 1 row. Yeah, 1 row. So row number 1, 2, 5. Yeah, very clear. So 1, 2, 5. Yeah. Third example. Let's go third example. Now in this case, I want everything, right? But in this time, uppercase version of name, I'm comparing with the uppercase version of Jane. How many rows? How many rows I will get in this case? Vanisa says 3, Kunjal says 1. How about the others? Molly, Zia, Casey, Liam. Yes, Liam says 3. Good. Lim says 3. In this case, a bit tricky, isn't it? Now again, think about this case. So what I'm doing here, converting the name column into the uppercase version, right? And comparing the uppercase version with the uppercase version of Jane, right? So apples with apples, right? So that means I'm converting um, everything or comparing everything with uppercase version of Jane. And then I'm getting the results, everything in the table, right? So which matches this condition. So that means this chain, that chain, every chain will be converted to the uppercase version, right? So that means I'll get 3 rows back, right? Every 3, these whole table I will get it as the results. Yes, so 3 rows, the whole, okay? Right, how about the next one, this example? Now in this time, I'm comparing the name column, but in this case, the lowercase. So I've converted to the lowercase and compared with the lowercase chain. How many rows again? Vanessa, Molly, good. Yeah, 3 again. Yeah. So completely to opposite to the first, this one. Yeah. Right. How about this one? Select everything from the student where uppercase version of chain is equal to this chain. This time, yes, 0. Good. No, nothing. Yeah, we are not comparing apples with apples. How about this one? The last one. Lowercase name equal to this chain. Again, 0. Very good. So you are not getting anything back. Yeah. Right. So makes sense now how to use uppercase and the lowercase. It's bit sometimes bit tricky. Yeah. So if you practice this, it will be not that difficult. All right. Right. Okay. Now we are moving into a new topic. Data. Actually, this one has to be the first topic that we should discuss in the very first day, right? But I deferred it for week 3, right? Now, one of the key reasons why we construct or why we create the database to get rid of these so-called data redundancies. Now, data redundancies actually create a lot of problems in the databases. One of the key reasons why we create the databases is to get rid of the redundancy issue, right? What do you mean by the data redundancy? Data redundancy means same information or same piece of data appears multiple times in the same database, right? Maybe it will appear in table 1, it will appear again in table 2, again in table 3, etc., etc. So if a same piece of data appears again and again and again, it can lead to some inconsistencies in the database, right? These inconsistencies are a very big issue, right? Because if you have inconsistencies, if you made some changes in the one part of the database, and if you forgot to do any changes in the other part of the database, then we have anomalies, right? There is no consistencies between the same pieces of data. For example, database can have multiple grades for the same subject, the same student, right? Right. So if you happen to see these sort of problem, then we can say, all right, there's inconsistency. There may be some redundancy issues, right? And sometimes if you try to delete something, for example, if I try to delete commerce order, it will eventually delete the customer as well, right? Because there may be some anomalies due to these inconsistencies or maybe redundancies, right? So this is evil for the database. So the main purpose of creating database to get rid of these inconsistencies, get rid of these redundancies, right? Right. So if you have a redundancy, so inconsistent or redundant data, in other words, the main reason why we have redundant data, because our entity relationship diagram or the schema that we built on the entity relationship diagram actually faulty. So we didn't follow the proper guidelines or proper conceptual underpinnings to model our databases, right, or model our relationship. So that is the main reason, right? So that may create a lot of anomalies, right? Basically, there are three types of anomalies can happen if you have inconsistent data or redundant data. So we may have insert anomalies, we can have update anomalies, or we can have deletion anomaly, right? So what do you mean by each of these? Now let's go through each of these concepts. Right, now let's go through, let's actually first go through the redundant data. Right now, this table is a poorly designed table with redundancy issues, right? Now imagine this. Now this is a small table. Now imagine we have a small business, say a small mobile phone repair shop in somewhere close to Swinburne University. So we may have create somebody who doesn't know anything about the databases may have create a kind of a table like this to record the employees and other details about our business, right? So we have employee number, right, and the name of employees, okay, and then branches in. So imagine we have two branches at the moment. One is in the Box Hill suburb and one is in the Kew suburb, right? So this is the branch details, which suburb the branch is, and then here we have the address of each branch, right, and then the phone numbers of each branch and the age of each employee, okay. Now, do we have the data redundancies? Yes. So if you go through this table very clearly, some data is redundant, right? So what are the redundancies that you can notice here? You can see the branch addresses, right? Branch addresses are recorded multiple times. For example, Q branch address recorded twice in this table, as well as the branch phone numbers are recorded twice in this table. So basically, we can say this is a poorly designed table with data redundancies, right? Right now, this will lead to some sort of anomalies, right? So let's go through these anomalies. And let's go through first anomaly, insertion anomaly, right? So by the way, if I go back, if you think about now, when you create a table, always you need to create primary key, yeah, or identifier. For this table, they have identified as employee number as an identifier because it uniquely identified each row in this table, right? Right, now let's go through the insertion anomaly, right? For example, now think about, so we are performing very well, our company, so we have decided to buy another branch in Hawthorne suburb, right? Hawthorne suburb, and my say for example the owner want to record this information in this table, right? But he can't do that, right? He can't. Now imagine that this branch is newly built and newly renovated one. So we haven't employed any employees yet in this particular branch. Okay, so there is no employees at all. So now we have a problem. So we now can't insert the Hawthorne branch details into this table, because the reason is because there is no associated employee in this particular branch. Why we can't record it in this case? Because you know the employee number is the primary key in this table, right? So if the primary key is not there, so we are not able to record this information, right? So why this problem happens? Because we have some anomalies in this table, because informations are repeating, and then that is the main reason we have the problem here, right? Now if you actually closely look at this particular table, or this particular kind of you can see there are two pieces of information actually they have recorded in the same table, right? So one is the employee related data information, and the second is the branch related information, right? So that is probably the reason why we have these anomalies, right? Because if you put everything together, some pieces of information can appear multiple times, right? And then some pieces of information will be not appeared at all, then we have in a problem to insert some to the table, right? So in this case, that is what happened, right? So there is no employee. Employee number is the primary key, therefore we can't insert the Hawthorne branch details into the employee table, right? So we can't keep the primary key null, right? We can't keep the name null, but we can't keep the primary key null value, right? So that's probably the reason. We can't insert this data into this table. So this is called the insertion anomaly. Okay. So let's go to the update anomaly, the second type of anomaly. Right. Now imagine that now we have these details. Now imagine we want to actually change our branch phone numbers, right? Branch phone numbers. So you can see the Q branch in this case appears twice, so as to branch phone numbers as well, right? So sometimes I may say, for example, while I am doing updates in each row, right? So I'm updating each row by row. So while I'm doing, say, for example, row 119, right? Maybe I have interrupted with somebody. Okay, maybe my son comes here and then he says, "Oh, Dad, I want to do something. I want to play with you," right? So then I play and come back, and I'm trying to do. I forget to update the second row, right? So that means now I have inconsistencies in my table or this database, right? This is called the update anomaly. So now we don't have a single truth with respect to the branch phone number, right? We don't know whether this one is the correct one or this one is the correct one, right? So which one is the correct? So this is called the update anomaly, right? Because the same table we have multiple times the same information appeared. So if you forget to update something or one particular instance, so there may be inconsistencies, right? So decisions are made in incorrect data, and eventually the users will lose the faith of the system, because they will get the conflicting information from this table, right? So this is called the update anomaly. Again, why we have the update anomaly? Because this table is poorly designed with multiple occurrences with the same information. Right. Then we have the third type of anomaly. This is called the deletion anomaly. Right. Now, deletion anomaly. What do we mean by the deletion anomaly? Let's go through an example again. Now we have two branches. Imagine that we have two or 3 branches, but we haven't recorded the third one yet. But imagine we have 2 branches at the moment. Box Hill branch, Q branch is the one we have, and Fred Brown is one of our loyal employees who are working at the Box Hill branch. He's the only worker working there, and he says, okay, I'm going to retire tomorrow, right? I don't want to, I'm going to retire. So now we have a problem. If I want to get rid of Fred Brown, right, from my table, what will happen? It will eventually get rid of the details of my Box Hill branch, isn't it? Because Fred Brown employee number is the primary key of this table, right? So if I can't delete the portion of this table, right? Delete means I want to delete the whole row, right? I need to get rid. So if you get rid of whole row means I will lose the primary key and I will lose everything about the employee branch as well, right? I can't keep the null primary keys anyway, right? So this is called actually deletion anomaly. So why we have a deletion anomaly? Because of that issue, because it's poorly designed, right? Because this actual table contains 2 types of information, integrated and some information are repeatedly appeared in the same table, right? Right. So we will do some example. Now this looks very simple. 3 examples with the anomalies regarding the tables if you have multiple occurrences, right? But sometimes in some instances it's a bit complicated. But we'll come to this a bit later on. The idea is behind this is when you design the tables, when you design your relational schema, you need to make sure there is no redundancy issues involved, right? That is why we follow this step-by-step approach to design ERDs first, right? And then we convert into the relation key schema, and then we convert into the tables, right? So they may have not followed these steps properly. That might be okay, why they have these 3 anomalies. So in this subject, basically, we are focusing on how to create good relational models, right? So if you create good relational model, eventually we can reflect better schemas. There is no redundancy issues, and then probably no redundancies means then of course we don't have any anomalies in the database that we created, right? So data anomalies usually, redundancies and anomalies usually happens because people who come into the database, discipline without having better proper knowledge, right, about how the databases are constructed, right? So basically, actually, in future lectures, we will show how to do the better design. So basically, the people who are coming into database without having kind of Excel, how the Excel works, Excel spreadsheet. So they may actually do a lot of issues in this because they have Excel mentality, right? So Excel is completely different because in Excel spreadsheet we can have a lot of redundancies, right? Same information repeats. But in this case, we need to actually avoid these kind of things, right? But we'll come to that a little bit later on. Right, so in order to overcome that problem, the better solution or the ERD for this particular problem is now looks like this. If I do a ERD, I will actually draw 2 tables, right? One for the employee and one for the branch, right? So employee details separated, branch details separated, and then I will establish the relationship something like this. So we know the employees are working for the branches, or branches have employees. So if I establish the cardinality relationship and cardinality constraints properly, then probably I may have overcome those anomalies, right? So by the way, once you created the employee table, I need to find out what is the primary key in this case. Definitely employee number is the primary key. And then I take the branch related information to the branch table, and then I record everything there. So branch code, branch address, and the branch phone number. And then of course I can say the branch code as a branch the primary key. So the branch code in this case means the the suburb, right? Suburb of that branch. So then we can put the relationship like this. So we know exactly one branch can have multiple employees, right? So one to many kind of relationship, right? So one to many. So we can put the foreign key at the employee side, right? So branch code goes to that side. So that means I have an extra column in the employee. That means the branch code appears there. So the branch code, when you goes there as a foreign key, that is not redundancy. Now remember that, right? That is not redundancy, right? So that is the minimal information we required to establish this relationship. Okay, right. Sometimes people may think, okay, if I put branch code there, that is a redundancy. No, because to establish this relationship, it's important. We need that information, right? Because of that, we can establish this link, primary key, foreign key link, right? So my cardinality is something like this now. So one employee must belongs to one branch, and one employee one branch may have many employees, right? May have many employees. Uh, so so now if I converted it to tables, or if I put into a separate tables, so now I have a separate table for employee with branch code. Now this is the foreign key, and then I have the branch table, right? Branch code is a primary key, so primary key related with the foreign key, right? So now my relational schema now looks like this, right? Branch code, branch address, branch phone number, and employee number, name, branch code, age, foreign key foreign key branch code, references to the branch. Okay. Right now, if I go back and ask these questions, right now, so imagine now we have created these two tables, right? We separated this information. Now, do we have the redundancies? By the way, do we have the same information repeated again and again? Right now, if you go through the employee table, of course, there is no repetitive information, right? Of course, the branch code is repeated, but this is a prior foreign key, right? It's the minimal information we require. So there's no redundancy issue in employee. Do we have the redundancy issue in the branch? If you go through one by one, no, there's no redundancy issue because each branch details recorded in each row, right? Right now, I can answer this question. If I go through these tables, so if you go through the earlier issues, can I insert a new branch? Now remember, I have bought a new branch, Hawthorne branch. Um, um, so can I insert the new branch without having any issues? Because in the Hawthorne branch, there's no new employees, right? In this case, yes, right? Because what I need to do is I need to insert a row into this branch table. It will not going to impact my employee table, right? So yes, there's no issue, there's no anomalies, no insert anomalies occurred because the information has been separated, right? So yes. Then data redundancy is eliminated. Yes, we eliminated redundancy. We went through it. Now, changing the branch phone numbers. Can I change the branch phone numbers without having any update anomalies, right? Yes, because now if I want to change the Q branch phone number, I need to actually change only one instance, that is the third instance or third row in my branch table, right? Here, this number, right? So earlier, remember that I have to update multiple times because of the redundancies, but this time I need to update only once, right, on this instance, right? So definitely I have get rid of update anomalies as well. Okay. And then Fred Brown is retiring. Can I get rid of Fred Brown details without impacting the branch details in this case? Yes, I can do it. Without having any problem. Fred Brown is the first employee. So if I delete this employee in the first instance, it will not going to impact anything in this branch table. So that means we avoided the deletion anomaly as well, right? So Shenal, you have a question. So sir, when the primary keys is vacha, can we input the same word both in the upper and lower cases? Um, uh, yes, yes, no problem. So I actually, I'm not so clear, Shenal. Can we come to that little bit later on about your problem, because I'll come to your problem. Okay, so can you please hold on? I'll come to that. Okay. So are you referring to this slide or something regarding my previous one? I think you were referring to previous upper and lower, right? So let's we come to that bit later on. Okay. So I'll come to your query. So let's finish this. Right. So so in this case, we removed all the anomalies, right? So update anomalies removed, deletion anomaly removed. Yes, Fred Brown, we can delete now. Update, we can update the phone number without impacting, uh, without having any problems. And also insert anomalies. Yes, we can put the new branches without having an employee associated employees, right? So we get it. So now can you see from this small example, it's a very Mickey Mouse example. If you create a table with redundant information, it will create a lot of issues, right? Three issues, three anomalies: update, delete, and insert anomalies. So to avoid that, we have to actually create a model with very good qualities of uh, data issue. I mean, with very good relationship has to be established by using some conceptual meaning. Um, so we design in that way, right here. So in this case, in this unit, I am going to teach you how you're going to design this kind of models, right? Reduce, getting rid of all these anomalies. Okay. All right. So why we have this kind of, as I mentioned, because literally people who stick with this application, right? What is this application? Excel application. If you stick with these sort of spreadsheets, of course, because spreadsheets doesn't have any relational modeling kind of sort of concepts there, right? We just put all the information in rows and columns. So there's very little relational modeling over there. So there's no foreign keys, there's no primary key, etc., etc. So therefore, lots of redundancies and anomalies can happen. People who use Excel and then try to design databases. Okay. So I have given actually some limitations of spreadsheets. So this is a basic knowledge that you can roll, right? So there's a limitation for the spreadsheet because sometimes people will like, do we really need the database for a small application? Because we can do the same thing with the spreadsheet application, but there are some limitation, right? So the first limitation is of course there's a limited number of rows we can record. I think in Excel latest one is 1 million or 1.5 million rows. But anyway, if you imagine a organization like a bank or financial institute, other financial institute, how many rows do you think the bank will record in a given month? Maybe billions or maybe trillions of transactional records, right? So it is huge, right? So spreadsheet probably will not suit in that application, right? And the other problem is with the spreadsheet is all the rows will get loaded and viewed at the same time, right? So even if you want to see a one particular single row column, we need to actually load the whole table. That might be the issue. That is one of the main issue in Excel spreadsheet. And then we can actually hide restrict some information accessing by the others, because if I want to share the tables, important tables, for example, employee details, their addresses, phone numbers, it's very hard to hide with the others to looking at to it, right? And then filtering and searching is a bit cumbersome with the spreadsheet as well. If I wanted to say, for example, if I want to view only the female employees who are working in the Melbourne branch who are earning more than $80,000, who lives in the Hawthorne or Camberwell or Kew branches. How are you going to do this kind of filtering if you have using a spreadsheet? It's a bit cumbersome. You need to write some maybe complicated, can be, but you can write some complicated macros or formulas for do that. And then the other important limitation is validation will be limited as well, because we don't know how, when the users enter some data, how can you validate, how can you ensure that the salary that people as users entered is not a negative number, right, etc., etc. So that's another limitation. And the most important limitation is auditing facility, right? If the users change something, sometimes it will be very because nowadays auditing is very important, right? If you do some changes, we need to keep track of who has done the changes at what time, right? And if someone else does do the changes, we need to have record of that change as well on top of that, right? So the lack of auditing facilities are one of the biggest limitation in Excel. That is one of the key reasons why most big organizations, apart from calculating stuff, we use Excel to record the information basically. And also absence of multi-user concurrency control. So for example, if two users trying to update the same cell or same pieces of information, or 10 users trying to update the same pieces of information, how can we ensure that multiple users are not trying to update, how they are not override each other's updates, right? So that is a main problem with the Excel. Even if you're sharing it through OneDrive or whatever, it's big. How can we make sure? Because sometimes we need to then shut down someone else's update until the other one is updated, right? We can't actually do that very often in today's business world, because it can be really fast. We can't ask others, can you please hold on, others are updating the cell, right? It take time. Time is very important factor, right? So multi-user concurrency control is a problem in Excel spreadsheet. And then the other one is the absence of security level. For different users, different user groups, it's very hard to put some security levels if you use the Excel kind of spreadsheet. But if you use database, of course, we can overcome most of these issues or the problem, right? But the downside of the database is learning, right? Training, it required learning, bit of training as well. Now that is one reason why Microsoft Access is not so popular. It actually earlier days, can you remember, this package comes with Microsoft Suits free of charge, but nobody is using it. Why the people use Excel, right? If they see the Excel and the Microsoft Access, they never, oh no, I don't want to use Access. I'll use Excel, right? Because the problem is, yeah, it need little bit training, it need little bit, this primary key, foreign key kind of ideas to be get learned. It's not that easy, I would say. That is why now it has been removed from Microsoft Office packages. So there are so many advantages of having databases actually, because there's no limitation for the data. So we can record any number. If we can actually buy the spaces, storage spaces nowadays, always. Most of the database is now cloud-based, right? So we can increase the storage spaces without having an issue. We can cater for even a very small single small application, or for a sophisticated application without having any major design problems, right? So it's very easy. We can adapt them. And one of the main advantage of having database is we can actually hide the complexities of a database, right, from the front end, some kind of front end application. For example, users don't know that they are executing a select statement or update statement or delete statement. They just simply clicking and click the menu bars, right, menu options. So the back end, the application itself convert all these clicks and drags and drops into SQL statements, and then it will interact with the database. So we can actually hide all these multiple complexities with front-end applications. So that is another advantage of having a database solution, right? Okay. So let's go to another small topic regarding some information regarding what are the things that we need to learn about tables and column designs, right? So small issues sometimes important when you're designing the databases, right? So as I mentioned before, in this subject, we put much of a little bit of time, most of the time actually, I believe, to learn the relational model, right? How the relational model operates, how we going to establish the relationship between the table, right? How can we put the foreign key constraints and primary key constraints and other constraints in given table, right? So these are the things we will learn. And so far we may have ignored some other fine details, like how we going to select the better primary key, right? So what are the things that we need to learn about when you specify the table, right? What are the things we need to learn, how we specify the columns, right? So these small bits and pieces sometimes are very important when you're designing a database. So we'll do a little bit of thing, right? Because we are not. Right, now first thing is, let's think about the primary keys. This is one of the main thing that database, when you're designing a database, that we are facing. If you have a lot of information in front of us, how we going to decide which piece of information or which attribute is the best attribute to represent the primary key. So there are things that we already learned some stuff, right? So if you choose an attribute, that attribute has to be unique, right? You can't have any multiple or duplicate values in that attribute. And also the other important thing is we can't have any null values in that attribute, right? Null values, right? If you have null values in that attribute, if you think that there can be null values in the future in that attribute, don't select that attribute as the primary key. Okay. And then the other important thing is primary keys usually tend to be very static, right? So you don't select any columns or any attribute that tend to be very cheeky. It's kind of be, if you think, okay, this is bit variable kind of data, it will keep change in the future, then probably that particular attribute not be a best candidate for a primary key in your table, right? That is something that you need to know. Because the reason is, that the primary keys need to match with the foreign keys, right? It has to have identical values with the foreign keys. So if the primary keys keep changing, so that means the associated foreign keys need to be changed very often as well. So it's not very good thing to do, right? So it is possible to have two different manipulation. I mean, sometimes when you face sometimes when you try to get some information, you will get lots of different columns. Looks like the primary keys. For example, sometimes if I collect some information, I can have employee IDs, I can have tax file numbers, right? So some case we have to decide which one we need to take it as a primary key in this particular table. Is it a tax file number, or is it a employee ID number? The tax file numbers, each individual have a unique tax file number, right? So until we decide which one is the best primary key, we treated this as a candidate keys. We call it as candidate keys. So sometimes the management, or maybe database manager, or whoever the management position, or whoever the team who managed this database, then they decide, okay, let's select ID as the primary key. So once we select the ID as the primary key, we no longer treat that as a candidate key. We call it as a primary key. All right. Right. So another important thing that I actually like to remind you regarding ages. Right now, remember the last example that which I have shown you. I recorded the age. If you go back here, yeah, this table. Now remember the age. Now this is very bad, isn't it? employee number, each employee. So why it is so bad, guys? Can you imagine why we should not record the age rather than recording the age? Which attribute, which piece of information do you think more suitable to record rather than recording age of employee? What do you think? Yes, Casey, you are right. Yes, Hannah, you are right. So date of birth, yes, Molly, you are quite right. Rather than writing the age, better to write date of birth. The reason is, yes, you guys correct. Because age keep changing every year, isn't it? Right? So that means we need to run some queries each year to update employee employee ages, right? So that is very bad, right? Very bad. Again, that can actually happen a lot of anomalies as well if you forgot to update it, isn't it? And that's one thing. And then the other thing about the type of data, right? If you use the birth date or date of birth, sometimes we tend to use a date type of data to record that. Now, if you use date type of data, oh, lot of issues, lot of problem, because date function is, or date type of data is actually create a lot of issues because you need to know a little bit of date, right? So if you actually Google the date arithmetic, for example, sometimes we may need to know, okay, who is elder than that employee, who is younger than that employee, right? Then we need to do some kind of calculations, right, using date functions, right? So we will learn that a little bit later on. Date function. So it is bit alarm bells rings if you use a date because it's a bit complicated. Now in this semester, I don't want to use date, right? Date type of data, but it's okay to use because we are not doing any calculation based on the date. It's okay to use date because, but I'm not too much of worried about the date because of this problem. But if you go to higher education and more advanced subject, probably you will tackle it because our main focus in this subject is to design the databases, how to design properly rather than go these kind of small bit pieces because it will sometimes divert your attention to something else. So let's ignore the dates for this semester. Let's take the date of birth as Vacha, right? But it's okay if you want to practice it. It's okay to use date time. Now, when you think about the date in Oracle, the date in the Oracle means actually it has a year, it has month, it has week number, it has a day number, it has an hour, minute, second, everything integrated into the date, right? So that is what we mean by the date. So we can slice and dice the date at any way we want, right? So that is a bit complicated, but you should know how to slicing and dicing it to comparison purposes. So we are not going to tackle that in this semester because of that reason. Okay. Right. Then the next thing is I like to actually mention. Now these are the small bits and pieces, practical stuff I actually come across in my life when I designed this style. I thought that I should share it with you guys as well. The other problem is with the addresses, right? Now my advice is if you want to design a database, if you have the addresses to record, so don't use one single attribute to record the whole address, right? For example, if you create a kind of a column called address column and watch say 200, right? And then why I'm telling that? Because the problem is then it is very difficult to search or sort or aggregate some information based on the data because in Australia, we have postcodes, right? By based on the postcode, we can aggregate some information. Okay, how many total customers coming from this postcode? How many total customers coming from that postcode, right? And then the sorting and searching all these stuff are really difficult. We can do it still if you have the put everything in the address column, right? Then you need to use lots of what you call string manipulation functions. So there are there are a lot of string manipulation functions. So it's a bit complicated. So in order to ease our work or ease our report generations and comparison or searching these things, my advice is break down the addresses kind of attributes into separate subgroups or separate sub attributes. For example, I can break the address into street, suburb, state, postcode, and then if I use this table, multiple countries, I can have another column called the country column, right? So you can see the address in this case actually spans through 5 different columns, or 5 different attributes, separate attributes. So each is different to each other, right? So I have just given an example here. Now the problem again here is the problem again. What is the problem actually? If you have this sort of addresses breakdown into the problem is if you use these tables or these databases in different countries. So for example, if you implement this in the UK, right now we have a problem, right? The problem is UK postcode. Now here postcode is of course numeric kind of value, but in the UK you have weird postcodes like this, right? So that means then again you need to think about it. For example, in this case it's okay because postcode I have recorded in a kind of varchar, but sometimes we may think it's a numeric value, right? Then you need to convert it, right? So these bits and pieces of stuff actually really matters when you design the databases. So think about these things when you design the database, right? So address specifically, right? Right. And the other important thing is when it comes to the numeric values and the text type of values in the column. So how to decide that? Do we need, now in this case, early example, we need to decide whether the postcode is varchar or the numeric. So likewise, we need to make decisions sometimes, right? So there are some advantages. Of course, you know these advantages. There are some advantages to having a numeric type of data, and there are some disadvantages associated with numeric type of data as well. So main advantage is if you have numeric type of data, like in this case the postcode, the main advantage is we can do very easy the validation, right? So digits are very easy to compare. Because it built into the system, right? So validation is very easy. And then we don't need these messy codes to put, right? Remember varchar, always when you refer into varchar we need to put the codes, right? So that's another thing that we can avoid that. And also, but this is not that important, less storage space. If you think about numeric data, it's actually consume less storage space. Nowadays it's not that big issue because we have plenty of, but when it comes to millions or billions or trillions of data, to storage space matters, right, to a certain extent. Disadvantages of numeric data type is when it combining joining digits with the strings. Probably we need the conversion, right? Sometimes we need to compare or combine some digits with the string, so we need to require some sort of string functions. It actually sometimes very complicated as well when you use the string functions. And sometimes some databases, probably it's very difficult to record the string numeric values because now I think they have actually removed this earlier. When I was a student at the Swinburne, those days, early days, we tend to have a student ID with some kind of weird number like X, right? So those days probably they may have used varchar type of characters for the student IDs, right? Then now they have updated the system. I don't think you guys got any X or any kind of this alphabetical character in your student ID, right? So early days, I had my student ID 10 or 15 years ago, got letter X there, right? So, okay, so that is another problem, another disadvantage. And then now you need to be careful when you're storing the numbers as text values, right? That is another thing, because sometimes when you think about, okay, let's consider a particular column as a varchar, and then we put the text that numbers as a varchar type of characters in that particular column. Now, for example, if I record all these stuff, right, say for example these 1, 2, and 19, 30, and we record it as a text characters in a particular column. Then if I want to sort these text characters, now remember when you record something in any column or any table, we can see the character, but how the computer or the machine actually understand is the ASCII version, right? ASCII code of that particular character, right? So ASCII code of text characters are not equal to ASCII code of numeric characters. Now that's what you need to learn, right? So if you store as a string, right? And if you want to sort this information or these string kind of characters, you will get your output something like this. This is a bit weird. That is not what we want to sort. So we want to count 1, 2, 3, something like that, right? So sequence is not properly appeared in your select statement because you have stored the numeric values as a character type, right? So that's something that you need to think about when you decide. So how are you going to actually overcome? Now, still, if you want to record the numeric values as strings, but you can still do that. What you can do is you can put leading zeros into these numbers, right? For example, number 1 can be recorded like 0001, right? Now you need to make sure that, okay, total numbers we are going to record is 9999. So that means 4 digits. That what we wanted to record as a text in our column. So we put a leading 3 zeros in the smallest number, right? So if I put like this, if you record your information like this, probably when you get it sorted, then of course you can actually overcome these issues, right? Leading zeros. Now the problem is, even if you put the leading zeros, so it may be a little bit of problem when you're trying to export data into a spreadsheet and do some kind of manipulation, right? Sometimes, or very often, we export data to do some manipulation because 001 will become 1 in the spreadsheet, right? Spreadsheet understands something else, okay? So sometimes, so in order to avoid that, also some organizations still what they do is, without writing, starting up their numbers in like this, they're starting the sequence at 1000, right? 1000, 1000, 1000, 2000, so that actually avoids that leading zero problem, right? If they wanted to use information in a spreadsheet. Okay? So you can see that you need to make some decisions, right? So these decisions are not so easy sometimes when you decide what kind of type of data you are going to record in a particular column, because sometimes you need to interview other users, management, and then decide with as a team, okay, this is the data type we are going to record in a particular column, right? So, right, so that's a very important thing, because if you don't do it in a correct, proper way, then probably when the management asks some report, then you need to go back and remodify the table structure again, right? That's a bit of cumbersome. Actually, you can do that if you are a consultant, right? If you are a consultant, you can ask, okay, give me $100 or $200 per hour, I will come and do it. I will do that. This sort of changes in the table, you can do it still, but it's not good ethical thing to do. Okay. All right. Right. Now we are coming to a new topic called composite primary keys. Right, now so far, guys, we have learned the primary keys with in a table, right? So far we have learned only one primary key or one column. I actually don't like to use the one primary key. It's one column primary key in a table, right? But most of the cases, it's not the same thing, right? Sometimes we need to have composite identifier. Sometimes we need to combine 2 or 3 or 4 columns in a specific table to make it one primary key or single primary key, right? It's not so easy, right? Now let's go through a small example. Think about a utility like Swinburne. We have buildings and rooms, right? So example, we have a rooms, right? For example, we record the room details in a table, right? For example, in this case, imagine we have a building details in a table. So imagine we have created a table like this with three columns or three attributes, building codes, room numbers, and each room have different capacities, right? So in this case, can I take the building code as the primary key? Of course, probably not. You can see the building codes has the duplicates, right? Then it's not possible. Can I take the room number as the primary key? Probably not, because you can see the room numbers have duplicate values, right? So the key case is the composite key. What does it mean? The composite key means we need to take two columns as composite to form a better primary key for this particular table. So in this case, building code plus a room number, both will in combine will form a better primary key, right? So EN404 is unique, yes. BA404 is unique, yes. SA404 unique, EN411, yes, right? So you can see EN's different room numbers, right? But still building code is same, right? But these two are unique, right? If you combine. So likewise, sometimes you need to make decisions like this, right? This is called the composite primary key. So how can I show that in a relational schema? This is how we show in the relational schema, right? So when I write the relational schema, I can underline both columns, right? Both columns to show the composite identifier. Now remember that this does not mean we have two primary keys, right? So always remember a table must have only one single primary key, right? That primary key can be a single attribute primary key or composite attribute primary key, right? So there is no multiple primary keys in any given table. So remember that, right? It's wrong to tell that there's two primary keys, right? So in this case, how many primary keys a relation can have? Always a one, right? Every table must have one primary key. It can be either one column primary key or multiple column composite primary key. Okay, right. So remember that. That's very important. Data types, right? So let's come to data types. I will go very quickly. Don't need to actually run too much of this technical stuff. Now you know the columns can record different data types in database management in databases, right? So we can record varchars, we can record numbers. So varchars basically characters, numbers means numeric data, and we can record a date type data, right? So when it comes to the varchar or the character type of data, we can have actually two types of characters sometimes. Now, varchar stands for the variable characters. So variable characters. Sometimes we can use char, right? Char means fixed length, right? So I actually avoid. I don't want to use. Asking you to avoid char type characters. Use the variable type character. Why we use the var in the first place? Variable means varies. For example, if I say a varchar 100, right, for a name, right? If a name, that what do you mean by varchar 100? The varchar 100 means the maximum characters you can record in that particular column is 100 characters, but it is variable, right? But it's variable. What do you mean by variable? Because if a one person name has only 3 characters, the other 97 characters will not going to they will not going to allocate into that particular row, right? So that means you can save 97 characters for a one single row in that particular name, right? But if you use char type, right, it's fixed length, it will not vary. So if you have even 3 character long name, it will still allocate 100 characters. Doesn't matter, right? So that actually consumes a lot of storage spaces. Okay, so avoid the char, use the varchar. That's a good practice. Okay, and then the numbers. When it comes to numbers, you know, we can record the numeric values using the numbers, right? So in the numeric, we can actually record decimal points, right? So if you want to write decimal points, you can separate it by the comma. So this is an example here. In this case, I want to record the test scores or test numbers of individual students. So that particular column has 4 digits, right? In total, 4 digits. From out of 4 digits, the last 2 digits is the decimal, right? So in this case, I can record data from minus 99.99 to plus 99.99, right? Including these two, right? So plus and minus, I can include the minus values as well, no problem, no, there's no issue with that, right? So that is numeric data. And the date, as I mentioned before, the date table or the date type of data encodes both the date with the time fraction as. So it comes to actually single second as well. You can actually break it down, right? So date and the time, everything is included in the date type of data. So that is why I just asking you to avoid this too much this time, because we are not going to use. Okay. Right, now we are coming to a little bit of SQL stuff. We can actually, once you create the tables, we can alter the tables later on, but I actually don't like this thing, right? Altering table is not good thing, but sometimes in some cases we need to do it in the real life. For example, now this is the syntax to altering the table, but this semester we are not going to do that. I don't want you to do the altering table. This is very risky in the first place. If you go to the index, it's very risky task to altering the table. So there are certain things that you need to keep remember. So you will learn this once you come to the advanced table stuff. So, but we are not going to use this, right? But for your knowledge, I'm just letting you know, right? So this is how we alter in the table syntax. So alter table is the keyword, then I need to specify the name of the table. So I can actually add some new columns to the table. So I can modify the existing column names or data length of the data, etc., etc. Even I can drop some columns. I can add some constraints or drop some constraints, etc. So I can do lots of stuff using alter table statement. Right now, this example give you one example how to add a particular column into an existing table called employee. So here I use the keyword alter table employee, that is the name of the table. So I'm adding a column name called merit status, right? So this is the name of the column, the data type of that column, and then I add a constraint called not null, right? So that's why you need to remember, because sometimes when you can modify the table without losing the existing data. So it will be a bit tricky as well. So I'm actually not a good fan of altering these tables. So in this semester, in your assignment, right, what you can do is, if you face a problem, or if you think, oh, I missed some column or something like that, don't use the altering table. So what you need to do is, you need to create the table, you need to insert the data, then you run the queries, and then if you think, oh, there's a problem, once you identify the problem, what you can do is you can drop the tables and recreate the table, right? Sometimes you need to go through these steps maybe 20 times or maybe 30 times. So when I learned this, actually, when I learned the database very first time, like you guys, right? I actually created my assignment. Those days, I remember 30-40 times. Those days, when I was a student, we have individual assignments, not the group assignments. So we 30-40 times sometimes I rerun, because I really love this subject, right? This kind of database. So I actually run a lot of times to get it learned, right? So I actually practicing you as well. This is how my teacher told me to do. So I thought that better you to do. I teach you as well the same thing because I learned a lot. So please go. Don't use the alter table function. Okay. Right. Right, now I am coming to another small topic, how the inserting multiple rows. Now remember when you are in your assignment also, maybe not too much, but you may have to insert 10, 15 records or instances to the given table, right? So rather than writing insert into insert into insert into like this, there is a simple way to add records using Excel, right? So sometimes what we can do is we can cut and paste and then we change these values, but it still crumbles something, right? So what I do is, this is what I learned actually. I can use the Excel spreadsheet to do that task. So what I can do first, now I know that what are the values I'm going to record. So I'll create, for example, if I want to create a 2-column table. So one first column records the student ID and the second column records the student names. What I will do is I'll open the spreadsheet first and then record all the column data values in two separate columns, like in this case column A student IDs, column B all the student names, right? And then column C I'll type, so for example C1 in this case in here. I'll type a small statement, right? Insert statement, insert command using quotes, right? Double quotes. So I just write like a formula. You know how to write the formula? Put the equal sign, equal, and then I write this as a formula with double quotes inside. So up to here, right? Value up to here. So insert into student, student ID, comma, student name, values. This is after this the value starts, right? So I'm not going to record that, but I will close the quotes, and then I'll come to D1 column, right? D1 column, and then I write another formula. So I put equal, and then I put a C1, right? C1 is this column, whatever the piece of data I have written here. And what do you mean by the and? By the way, and means you need to combine something, right? And in the Excel means combining, right? And A1, right? So you know exactly after this this statement you need to record some value, right? So C1 and A1 means the value of this cell, right? So A1, then and, right? And then I put a comma and a quote, right? Because you need to separate the first value with the second value with the comma and the opening quote, right? So I put that inside the double quotes, this comma and the quote, and then I put another and, right? And then I will add this piece of data, right? So that piece of data actually in B1 cell, right? So B1. Then finally I put another and then I close the close this particular statement, right? So inside again double quotes, I close the last piece of this particular statement, right? And then if I press enter, you will see the nice insert into statement populated like this. Then the rest is very easy. So what I can do is, can you see a small, I don't, you may have noticed there's a small box in the Excel cells, right? So you right click it and drag it, boom, bottom. What will happen if you drag it? It will populate this cell with an appropriate values, right? Appropriate values with corresponding values with corresponding values. So that's easy, right? So this is something you can actually do in your assignment if you wanted to you know, practice it, right? So this is something I like to show you. Okay, Right, so in your assignment, guys, as I mentioned before, use that text file that I have given to you. Remember the assignment, you need to record all your statement in this text file. So your text file now looks like this. Make sure you use the text file in the appropriate places. Put the comments in the appropriate. I think I have put the most of the comments. But if you want to put some comments, you just put comments like something like this, right? Shenal, you have a question. What is the question? You mean you didn't get this one? So what you need to do here is what I have told is to record two different formulas in cell number C1 and CD, right? Because here we are breaking insert statement into two pieces, right? The first insert statement, we just record this text, and second insert statement in the D1, we record the values, right? So how are we going to record the values? Something like this with the and sign, because we need to integrate the first statement with the values. Okay, and then press enter. If you press enter and the D1, you will get the nice statement like this, right? And then all you want to do is from you will see every Excel cell, you will see a small tip like small box in the cell corner of the cell, right hand corner, bottom right hand corner, and you can drag it and drag it down, and then what will happen, it will populate the insert into statement with an appropriate corresponding data values with these data values, right? So you can save a lot of time. That is what I told you. Okay, makes sense. All right. Okay. Right now, once you created the tables, right, and maybe in the assignment, probably 10 or 5, 10, around 10 table, right? 7 or 10 table, I can't remember. So how can you see, how can you list the tables that you have created in your database? So this is the command, right? So we usually access what you call Oracle Data Dictionary, right? So remember, Oracle is keep all your information, including your table, as a table, right? Inside another table called a user table, right? So inside the user table, it will have all the tables you have created. So if you can access the Oracle user table, then you can access all your information. Okay. All right, so this is how we access it. This is how we list the tables, right? So the table, the user table, they call it as user underscore table. So select use table name. This is the column name. In the user table, you may have lots of columns. One column is called the table name column or table underscore name. So if you access that, if you select that from this user table, you will get the list of tables you have created, right? Now Oracle have a kind of a very strange name for the user underscore table. They use the term tabs. I don't know why, what is the reason, but they use the word tab, right? So shortcut version of this, right? I don't, maybe because of that. Right, that is one thing. And right now let's come to another thing, another important command. Delete command, very risky command, right? Can I delete the records from the table? And this is how you delete the records, right? So how to delete a table? Drop table command. How to delete a record or instance? Delete command, right? So this is the command. This is how we use, this is a syntax. So delete keyword followed by the table name, right? And then make sure you put the where clause. Now that is very important, guys. If you forget to use the where condition, what will happen? Bang, whole table, whole record will go on, right? So you can't recover it, right? Now delete command, very powerful. That is why most of the database administration don't give any kind of access, or prevent access for delete command for users, or most of our users even. Okay. Now this is how we use it, the delete command. Now here in this case, I want to delete a student, right? So delete some student from a table. So delete student. This is a table name where I want to delete all the students who didn't pay the fees at all, right? So upper fees paid, so I converted the fees paid column into the uppercase version, equal to n. So who didn't pay the fees, I want to delete them, right? So this is how I do that. So this is very important, where clause condition, right? If you get messed with this, then you are deleting the wrong students, right? That's very, very dangerous, right? So there is no undos, right? There are undos, and then if you just execute without a where condition, it will delete all the rows from the student table. So pretty much dangerous command. So in practice, what I'm actually doing, right? What I did in my practice, when I'm working in the industry, what I did, rather than writing the delete command straight away because it's too risky, I actually write a select command first, right? I write a select command. So I write a select command like this. Now, if I want to say delete all the students who are not paid, I will first run the select statement, and then once I get the result set back, what I will do is I'll go through the result set and I'll verify it whether this is the students we want. Yes, that's right, correct. I get verification from management. Management says yes, Pravinder, that's what we need to delete. And then I simply, what I do is I replace select from with the delete keyword, right? Because once I make sure, then I can delete and then press enter, bang, it gone, right? So that is a good practice. You can practice that as well rather than directly deleting it. So first run the select statement, verify your records, and then replace the select statement with the delete command, right? That's what my advice is. Can I update some sales or some instances or some records? Yes, I can do that. How can I do that? By using the update command, right? This is how you can use the update command, right? So update the name of the table, right? And then I use the keyword called set, right? Now that is important, right? Always when you use the update, make sure you it's actually very dangerous, like the delete, all right? Because if you forget to put set, sorry, if you forget to put where, set is required, because in the set we are specifying which column we need to update, right? And then if you again, the where is very important. If you forget to put the where, it will update the whole instances, all the records in that column, right? So it's very, very dangerous command again. So update set the column name, and then the new value, which value we need to update, right? I can actually update multiple columns if I want. If I want to update multiple columns, it has to follow by one set keyword, only one keyword, but we put multiple columns and the new values followed by a comma, right? And then finally where clause. This is the condition, right? Which columns or which rows I wanted to update, I will put that inside this where clause. Okay, so this is an example again. Early example, I want to update student table, but in this time I wanted to update fees paid column of the student table to Y, uppercase Y. So I wanted to update it because some students have paid the fees. So who is paid the fees? This student paid the fees. So I put where clause, where student ID equals, so this number. Okay. So again, warning, as I mentioned, you need to be very careful to write the appropriate, make sure you select the appropriate condition. So again, there is no undos, right? Undo feature, right? If you updated, that means that's done, right? So again, my suggestion is before update, use a select statement, run the select statement, verify it with the management, whoever responsible, and then check the rows again, and then convert the select statement into the update statement. Okay, so that is the process I followed. Please make sure you also follow the same, so you will actually less prone for the errors. Right, so this example actually I give you an example of updating multiple columns. Okay, so here I am updating the employee table, so update employee, but I am updating multiple columns, right? So what are the columns I am updating? I am updating a salary column, right? I want to increase the salaries by $5,000. So salary is equal to salary plus 5,000. And also I wanted to give some allowances to some certain employees. So my column called PZ allowance increased by $1,000. So 1,000, right? But I don't want every employee get these updates or these salary hikes and the PZ allowance, but I want only certain employees. So then I write the where clause, right? So where I want the people who resides in the Hawthorne branch, so upper branch, Hawthorne, right? Or years of service greater than equal to 10. So people who are reside in the Hawthorne, or people who have more than 10 years of service, I'll give them a salary hike of $5,000 plus $1,000 PC allowance. That is what we mean by this claim, right? So this is very important, right? Where clause, if the condition is wrong, you are actually updating the wrong people in your table, right? So very important. So run a select statement first, and then you do the update second. That's my advice. All right, now we are coming to the last part of today's lecture. Now, so far we are coming back to ERBs again, right? Modeling. Now forget about SQL for a minute. So we are coming back to our modeling part. So each week we are going like this. Sometimes we are do modeling and then come back to SQL. Sometimes we go SQL and then coming back to our modeling, right? That's how we go, right? So let's now move into our modeling last section of today's lecture, modeling. So multiple relationship between entities. Now so far we have learned the relationship between binaries. Binaries means two entities but single relationship, right? Can I have multiple relationship between two entities? Yes, of course. Now this is a classic example. Okay. Right now, imagine I am a small company, right? So say for example, Glen Ferry, that particular small phone company, right? I am maintaining two tables and a separate tables regarding my vehicles and the dealers who I am purchased with these vehicles, right? So I have a table called, or the entity called car, right? So three columns or three attributes. So I record the registration number, model of the car, color of the car, etc., etc. And then again, I have another table called a dealer table, right? So I record dealer information from whom I purchase these vehicles. So dealer names, their phone numbers, and their rating codes. I thought it's very important. And at the same time, I wanted to record two relationships between these two, because I want to record the I want to keep a track of whom I purchased this vehicle or the cars from. At the same time, I wanted to keep track of who is the dealer actually service these cars, right? So therefore, I have two types of relationship: purchasing relationship and service relationship, right? Two relationship. Okay. Right, so two relationship means, now in this case, you can see now where is the foreign key column goes? Always foreign key goes into the many end, isn't it? Many end. Now here we have one many end, we have another many end. So there are two many ends actually attached to it. What do you mean by these two many ends? So that means the primary key of the opposite end, or primary key of dealer names, come twice, right? In this table, isn't it, as the foreign key? How can that happen? That may be a problem, isn't it? So let's sort out first. Right now, so we need to treat each relationship separately, right? So how many relationships we have? Two relationships: purchasing relationship, service relationship. Okay, now let's take the first relationship, purchase relation. Now again, if you think about single relationship, The relationship can be established in both direction, right? Left to right, right to left, right? So let's take first purchase relationship and then establish that one, right? So how can I read this one, right? So let's start with, again, always you need to start with one, right? So one car uh, must purchase from one dealer, right? One car must purchase from one dealer. So by the way, I have established the cardinality relationship together with cardinality constraints, right? These are the cardinality constraints. These are cardinality relationships. So again, cardinality relationship and cardinality constraint, right? So the first one, one car must purchase from one dealer, right? And then right to left, one dealer may sell. So you need to actually revert the other way around. One dealer may sells many cars, right? Okay. So what do you mean by this mandatory or this constraint here? One means, what do you mean by one? So that means if you have a vehicle here, the dealer's detail or dealer name must appear there. So that means you can't have a null foreign key. So that is what we mean by this, isn't it? This is what we mean by this. So foreign key must appear in the other side. Okay. So that is what we mean by the first relationship. So one car must purchase by the one dealer, and one dealer may sell many vehicles. Right. Right. Now let's move to the second relationship. Now we need to separately identify that. Again two ways, right? Left to right, right to left, right? So let's read this relationship. Again, start with one. So one vehicle or one car may be serviced by one dealer, right? May be serviced by one dealer. And then right to left, one dealer may service many vehicles or many cars, right? Right. So that, what do you mean by this? What do you mean by this may, right? So we know this is mandatory. This is called the optional, right? Optional cardinality constraint. So optional means the foreign key can have null values, right? So that means my dealer name may or may not appear in a corresponding row, right? So that is what we mean by this may, right? Optional. So mandatory, optional. So mandatory means not null, optional means null. Okay, right. So right, so we now have how many foreign keys in this case? Two foreign keys, right, in the vehicle, right? One, and here two foreign keys. So how can I write, when I write the create table statement? Now you can see the dealer name, right? That is a foreign key, comes there twice, two times, right? Can I write the same dealer name there? Right, that is a problem. Right, now let's go to the next slide. Right, now if I write the create table statement for the vehicle or the car, right, so I have regio number, model, color, and then uh, two columns, right? Two columns, dealer name columns. I have the foreign key, one with the not null constraint. Now here, how I put the not null constraint, right? This is not null, yeah. The other one can have null values, right here in this case. So foreign key dealer name references dealer, foreign key dealer name references dealer, right? So I have two foreign key references. So in this case, you can't actually execute that because we have the same column name, right? Now remember, I think I have talked this before. I think I mentioned that foreign keys can have different names. So what matters is not the name of the column. What matters, what are the values inside that column? Is that values corresponds to the values of the primary key? That's what actually matters. Okay, so therefore we can actually give two different foreign key names without having any issue. Okay, so I can actually tell, I can rewrite the same thing The first one I can actually rewrite as of that is my purchasing dealer, right? Because that is my purchasing dealer, right? So the first foreign key is my purchase dealer name, okay? And the second foreign key is my service dealer name, but both are actually referring to the same column in the dealer table, right? So that is perfectly okay as long as you write these foreign key statements, right? So automatically the database management system automatically relate these new foreign key columns with the primary key column, right? So so this is okay, right? So this is not a big issue. But big issue comes when we try to run the select statements, right? Because we need to be extremely careful when you write the select statement, because now the values in a single row maybe refers to multiple rows in this table, right? Okay, because if you think about a single vehicle, right? A single vehicle can be purchased from one dealer, right? A vehicle can be purchased from one dealer, but it can be serviced from another dealer, right? Okay, so that means that value may be attached to a different uh, row in this table, right? So that's something we need to be a bit careful. Yeah, so here in this slide, I have explained why we can have two different foreign key names. The reason is we are considering only the value, but not the column names, right? So value is important inside the column, not the name of the column. That is not how the Oracle is matching the foreign keys and foreign primary keys. It's matches only the values. Right, now imagine we trying to populate the table. Now I have given some sample data, so I have bunch of dealers here. So dealers here, bunch of dealers, 3 dealers actually: Hawthorne, Mazda, Richmond, Good Cars, and Q Toyota. Okay, and then there are corresponding phone numbers right there. And then same time I have bunch of records in my vehicles or car table, right? So I have 4 cars basically. So they are registration number, models, and vehicles, and these are the 2 foreign keys, right? These are the 2 foreign keys. So you can see the first vehicle, the Mazda white car, we bought it from the Hawthorne Mazda, right? But it's serviced from someone else, Richmond Good Cars. The second one, I bought it from Q Toyota and serviced by the same dealer, right? So no problem. The third one bought from the Richmond Good Cars. Yes, the same dealer is servicing. But the fourth one, the last one, I bought it from the Q Toyota, but nobody else servicing. I am servicing by myself, right? That's why I have null. Can I have null values, by the way, for the service deal? Yes, right? So service deal, I can have null values here, right? So that is why I have null values there, okay? Right now, say for example, if my boss asking me to, okay, Ravinder, can you please produce a report? I want all the vehicle details and who is we bought this vehicle, so dealer name and their phone number, and who is serviced that vehicle, and who is the phone, what is the phone number of that service dealer, right? All right. So so what I do is, now I know I need to grab some information, both tables, 2 tables, right? So that means I need to use the inner join command, right? So if we use the inner join and information coming from 2 tables, now remember we need to use the aliases, right? Remember the aliases, right? Right. Let's write down the select statement. So this is how we write down select statement. So registration number coming from the car table, right? So C, I tend to use a letter C for the car. That is the alias. And then the purchase dealer name is again comes from the C table. That is my foreign key of the car table. Okay. And then that corresponding dealer's phone number is coming from the second table called dealer table, or D table, D dot phone. Okay. And then next I want the service dealer's name of that vehicle, right? So it coming from, again, that is my foreign key, come from the car table. And then the corresponding that dealer's phone number is coming from the dealers. So D table, right? And from car C, then I'm joining these two tables together. I use the inner join in this case, right? Inner join dealer D, and then I write the foreign key primary key relationship. Now in this case, I have two foreign keys, right, corresponding to the same primary key on that table. Okay, so what I do is I write something like this: on purchasing dealer name, this is my first foreign key C, right, equal to dealer name coming from D table. Okay, and then and second foreign key C table equal to primary key of the D table. Okay, so you can see that now we are referring to the same column, right? Now Oracle or any database management system will totally confuse by this statement, because here what we are doing is a single row in the service, or sorry, vehicle table is trying to access. If it is a single row, that will be fine, because dealers' phone numbers, different dealers' phone number, because it can be purchased by one dealer, service by another dealer. We are trying to access in multiple instances or multiple records in the second table, right? So it actually can't focus correctly because of this issue, because we are referring to the same two different two different actually instances sometimes, because one dealer may be in the one first row, maybe other row in the other row, right? So what we will get here is what it will produce something like this. So the vehicle name, this is the purchasing dealer name, right? So the phone number and the second service dealer name, right? And the phone number. You can see the phone number in this case is equals same, because Hawthorne Mazda Richmond Mazda is actually located in two different rows, right? So one row referring to two rows in this case, but in this case you can't, Oracle can't handle that. So that is the reason they grab the same phone number, which I think related to the Hawthorne Mazda. So this is the problem in these kind of situation, right? So we need to overcome that problem, right? Because SQL cannot handle the inner join. If I use the inner join that reference to the same table twice, then that problem arises. So that's the main cause for this problem. Okay, right. So what can we do is there's a one, or the first, or the one alternative is, okay, somebody can say, why don't you actually separate these dealers into two tables? We can have one table for purchasing dealers and one table for the service dealers, and create two tables so the work is finished. Why you bother too much? Someone can request that, or suggest that. So can I do that actually? Can I do like this? I can still do it, but then we are coming to a problem. What is the problem? If I separate this information into two different tables, the problem is what? Redundancies. Remember the redundancies? Because same dealer information will appear twice in two different occasions, two different tables. We don't want redundancy. What happens if you have redundancies? Anomalies. We can have update anomaly, we can have deletion anomaly, we can have different types of anomalies. The anomalies, remember, we just talk, right? So we don't want that to happen, isn't it? So so we need to actually get rid of that, right? So we can have a guys, can you just give me a 1 second? Just give me 1 sec. I'll be back, right? Just Sorry guys, somebody has come and knocked my door, so I just so right. So this is the problem. So we can't have the same information appeared in twice in two different tables. Um, right. So I can have kind of a this sort of table, so it will not work because of the redundancy. So I need to now have another look. So what is the another option? What is another way of handling this? So what I can do actually is we can actually trick. We can trick the Oracle or the database engine to think, okay, think as two tables. Think you have two different physical tables, right? So how can you make the database engine to trick or to think like there are two tables, right? So what we can do is we can actually create another alias, right? If you create an alias and you can refer the same table using two different aliases, right? Then of course, then the Oracle will think, okay, there are two types, two different tables, right? Actually, there's no physically two tables, but there are two logical tables. By we can create two logical tables, creating okay. So what we can do is we can have two aliases to refer to two logical tables. We can call, okay, let's call PD as our purchasing dealer or purchase dealer. Let's have another alias called SD for our service dealer, right? So no physically no two tables, but logically we created two tables. Okay, that is what we have done. Right, so what we can do now, right, so let's go through the steps first, right? The first step is let's write a query that uses the dealer table with alias called PD to record to grab the information regarding purchasing dealer details, right? This is how I write, right? So this is a simple select statement with one inner join. So first we grab purchasing dealer details, so registration number of the vehicle, purchasing dealer name, and then the PD phone number, because PD is now my purchasing dealer, right? Car C, and the dealer in this case I gave the alias PD, right? Now here I have separated. And then foreign key, primary key, this is the foreign key, C dot purchase dealer name, and then the primary key is located in the PD table, that is my dealer name, right? Right, so if I just execute this, I'll get this information, so that's quite okay. And then the second step is let's move to the service dealer part. So I write this similarly another select statement to grab the service dealer details. Again, the registration number coming from the table C, service dealer name coming from the table C, that is the foreign key. And then this time the deal I have created another logical table of giving another alias to the same dealer table. In this case I call it as SD, right? So SD dot phone number, okay, and then from car dealer SD, inner join dealer SD, and then foreign key C dot foreign key name equal to primary key. Now in this case comes from the SD table, right? Right, so this is step 2, right? Then the step 3, we can combine these two together, okay? This is the step 3. So when I combine, so I have now two inner join, right? One is the purchasing dealer, the second one is a sales dealer, okay? So two separate areas, okay? But the rest is actually quite easy, right? So in this case, I grab the first purchasing dealer details, which will just, okay, and then the first phone number coming from PD, that is my purchasing dealer, and then this is my service dealer name, and the second phone number coming from the service dealer logical table, okay. Right, so then now remember to put two inner join, right? So same table but two different aliases, so that means we created two different logical table, not physical table, logical table, right? So each logical table has foreign key and the primary key with the the existing vehicle or the car table. So again, the foreign key and the 5-digit. So once you've done that, of course, now you will get two different phone numbers rightly corresponding to the each logical table. So that is the right this is the right answer for in this case.